In the last video, I showed you how to calculate some probabilities to do with normal random variables, stuff like what's on the screen now. So just take a look at what's on the screen and see if you can figure out what that question mark is. Pause the video, give it a go, make sure you know how to do it. Hopefully you've been able to do that fairly easily. If you're looking at the screen and have no idea, then you've got the wrong video. Go back a video. But I'm not going to go through it. Hopefully you've been able to do it. Here is what we're going to do this time instead. Oh, I'm going to do that again. Just take it. I was quite proud of that. This is last time. This is this time. So what's changed? I have given you a probability this time and asked you what value this is here. So we're going backwards. Instead of finding the probability, we're given the probability and we're finding this value. I'm going to do a little sketch of that because that always helps us to get our head around things. Okay, bell curve this time. Mean at 40, and I've said this area 0.4. Have a quick think about why I know that is to the left of the mean, and I've asked you what that value is there. Okay, now we could use the function on our class viz from last time, the normal CD, and just do a bit of trial and error. So let's try that first. Normal CD, we've got a lower bound of negative infinity, which right is negative 999, an upper bound of, well, this is the bit that we're trying to guess. Let's guess at 30. Standard deviation here of 5. Mean of 40, and let's see if that's going to be anywhere close to 0.4. No, it's not. Let's try something a bit bigger. Maybe 39. Let's go close to the mean. Is that going to be close to 0.4? Hey, that's loads closer. That's going a bit too far. One more try. 38. Oh, it's gone too far the other way. I'm bored of that already. Thankfully, the calculator has a mode that will do it for us. We're going backwards, so it makes sense that it's called the inverse normal. Option 3, we tell it that the area is 0.4, standard deviation, mean, and it's going to tell us that A is 38.7. It's as easy as that. Okay. Quick summary of that. Inverse normal function on the class viz, we tell it what the mean and the standard deviation is, and we give it an area or a probability, and it gives us A. Importantly, the probability for this function needs to be in this form. Our random variable less than a certain value. There are some trickier questions that have come up where we're given probabilities in different ways, and we have to manipulate them so that they look like this before we can plug them into a calculator. Before we get onto those ones, here's another straightforward plug it in your calculator one. Give that a go now. Okay, I'm going to do that one myself. We've got, well, a sketch first, obviously. We've got a mean of 85 and an area of 91.92. So that's going to be bigger than the mean this time. again, have a think about how I know that that's definitely bigger than the mean if it's 91.9, no, 0.9192. And we're asked for this value here. Okay, let's plug it in. 0.9192. Standard deviation of 5 again. And a mean of 85 this time. 91.99. I'm going to round that off to 92.0. Well done, have you got that? Okay, a slightly trickier one coming up. Have a read. You can see that the probability this time is given in a different form. But we should be able to, again with the help of a sketch, split this up into ones that we can plug into our calculator. So a mean of 24 and an area from x up to 24 of 0.2. Have a quick think yourself about how we're going to split this up into two different probabilities that we can write down. Okay, I'll give it a go. So this probability here, the probability that x is between little x and 24, on the picture this becomes fairly easy to see how we're going to split it up. So this is going to be the probability of everything less than 24. X is less than 24. Subtract this area down here, the probability that x is less than little x. We can find this one. This one's got a value in it. We can find it using the normal CD button on our calculator. In this case, because it's the mean, we don't even need to use the normal CD function. It's 0.5. And that whole thing we know is 0.2. At some point I'll get better at writing on the computer like this, but that point is not today. Okay, swift rearranging in your head that probability now. A straightforward less than probability that we're going to be able to plug in our calculator is 0.3. Oh, I'll note this on as well. Sigma is 3. Let's plug all that in. Normal inverse. Area of 0.3. Standard deviation of 3. Mean of 24. There we go, 22.4. We get out that x is 22.4. Quick sanity check, is that less than the mean? Does that make sense? Yeah. Probability that our random variable is between 22.4 and 24 is 0.2. Great. Okay, I've had enough of writing on the computer. Let's minimise that. I have 5 questions for you to do there. The first 2, straightforward. Part C is like the one that we just did. You've got to split it up. Part D, use a little bit of extra information about random variables that I'm sure you can remember. And part E is like a challenge. That one's quite tricky. Give them all a go, pause the video and play it again once you've got them. I'm going to put up the answers to A and B really quickly. I don't think they need going through. Here they are. There we go. X is 13.0 and I just included B to make sure that you remember that these two symbols for a continuous random variable, like normal random variables, that these two symbols work in exactly the same way. Okay, part C now. Let's see that answer come. Ooh. Boom! There we go. I had to move down and run out of space. Okay, I got that B was 13.2. I've had to use two functions for this. At this point, I use the normal CD to get the probability of x being less than 10.5, and then I had to change back to the inverse to get what B was at the end, 13.2. Okay, part D. Let's go over there now. Here it is. I got K was 11.0. We have to use, for this one, the fact that all the areas underneath the normal curve, this one and this one, add up to 1. So to get a less than from a greater than, we just do 1 minus. Okay, now part E is the tricky one. It should appear here. This one I enjoyed doing. We have to use the symmetry of the curve. So if we know that this middle area is 0.8944, then the sum of the outer areas is 1 minus that, because it all adds up to 1. But the symmetry tells us that these two are exactly the same. So 2 lots of this bit is 0.1056, half it, inverse normal, find t. I like that one. This just requires a bit more practice. You really get used to the normal distribution curve and using these functions through that practice. Give it a go, good luck, hopefully enjoy some of the problems.